Good morning. My name is Sophie. I am a maths tutor and founder of Tutor in a Box. And today we're going to be looking at standard form. So this is a topic that comes up on both the foundation and the higher tier papers for the maths GCSE. And it's really just a way of writing really big numbers or really small numbers. As mathematicians, we can tend to be a little bit lazy. So it just helps us to write very big numbers or very small numbers in a clear and concise way. So let's get started and let's share my screen. So, oops, that's the wrong screen. Cool, okay, so hopefully you can all see the white blank paper in front of you. And so there's a couple of golden rules with standard form. So the first is that the number at the front has to be between 1 and 9.9, okay? So the number at the very beginning or at the front has to be between 1 and 9.9. So for example, you could not have standard form that starts with 16. You couldn't have standard form that starts with 78. You could have 7.8 or 3.4. Okay. Second thing with standard form, if we have a minus symbol at the end, the number's very small. Whereas if we have a positive sign at the end or no sign, the number's very big. Okay. And rule number 3, it's always times 10 to the power of something. And we'll explore that in a little bit. But we have our standard form number at the very beginning that's between 1 and 9.9. We have a negative symbol at the end. The number's very small. If it's positive, then the number's very big. And it's always times 10 to the power of something. So let's get some examples. So for example, 1.3 times 10 to the power of 2. Is that a standard form number? Yes or no? The answer is yes. 5.7 times 8 to the power of 2. Is that in standard form? No, because that times 8 is not standard form. So that's not standard form. 3.9 times 10 to the power of minus 5. Is that in standard form? Yes. So it doesn't matter the fact we've got a minus there. It just means the number's really, really small. And one final one, 72 times 10 to the power of 4. Is that in standard form? No, because 72 is bigger than 9.9. So that is not in standard form. Okay, so now you've kind of got an idea of what standard form is and what it looks like. Let's give some actual examples. Okay, so for example, write the number 5,200 in standard form. Okay, in standard form, that becomes 5.2 times 10 to the power of 3. And the reason for that is our decimal goes here. We go 1, 2, 3. So we're just working out how many places along it would go. Let's look at another example. So 5, 9, 0, 0. Let's make that a bit bigger actually. Whoa, that 0's gone a bit funny. Cool. Okay. So 590,000. And in standard form, that becomes 5.9 times 10. 1, 2, 3, 4, 5. So it becomes the power of 5. Let's try another one. 3,000. That becomes 3 times 10 to the power of 1 2, 3. Okay, so with standard form, it's just a way of writing very big numbers or very small numbers. Now, so far, we've only looked at big numbers. So these are all positive, the 3 here, the 5 here, the 3 here. But let's take a look at negative numbers next. So what about 0.00, whoa, 0.005. Okay, so to write that in standard form, that would be 5 times 10 to the minus 1, 2, 3, 4, 5. Yeah, let's try another one. What about 0.00023 this time? And that would be 2.3, because remember our number in standard form has to be between 1 and 9.9, so we couldn't have 23 in standard form. So we're going to have 2.3, and that's going to be times 10 to the minus 1. Whoa, that was a bit of a big jump. 1, 2, 3, 4. So it becomes 2.3 times 10 to the minus 4. Okay, let's try one more. 0.0000007. So this in standard form would become 7 times 10 to the power of 1, 2, 3, 4, 5, 6, 7. And remember, because it's a decimal, it's minus 7. So it becomes 7 times 10 to the power of minus 7. Good. So far we've covered writing out numbers in standard form. So writing out very big numbers or very small numbers. And remember, if it's a small number, so it's a decimal, it has a minus sign in front of the power. Whereas if it's a very big number, it just has a positive number. Okay. So in an exam, you might get a question that says, write out the number in standard form. And that is exactly what we've done here in all these examples. You might get a number that asks you to work the opposite way. And so it might say, write out the number 2.3 times 10 to the power of 5 as an ordinary number. And that's exactly the same practice, exactly the same way as we would. This time we're going the opposite way. So because it's a 5 there, it's not negative, it's going to be a big number. So we're going to have 2, 3, 0, 0, 0, 0. So we're going to go from here, 1, 2, 3, 4, 5. So that becomes our final number. Okay? Let's try another one. 7.8 times 10 to the 4. Okay, that becomes 7, 8, 0, 0, 0. Because then when we add in that point, it would have been 1, 2, 3, 4. Okay, so there we have 78,000 as our ordinary number. Let's look at one more with a decimal. So let's look at 0.0. Let's write in standard form 2.1 times. Actually, let's make it a little bit easier. Let's go with 2. So 2 times 10 to the minus 5. Whoa, maths has got a bit funny there. Okay, so again, same thing here. We're going 1, 2, 3, 4, 5. And so our number as an ordinary number is 0.00002. Cool. Okay, so far we've been looking at writing a number in standard form and writing a number in ordinary form. Okay, and there's a couple more bits that you need to know about standard form. Okay, and the next thing we're going to be looking at is multiplying and dividing. Okay, so multiplying, dividing numbers in standard form. So let's get an example. So 2 times 10 to the power of 3 times and we'll pop them in brackets. Okay, so multiplying and dividing a number in standard form. We've got 2 times 10 to the power of 3 times by 6.75 times 10 to the power of 5. So we've got two different examples. Sorry, we've got one example to begin with, but two different numbers in standard form, and all we're doing is times. Okay, so the golden rule when we're timesing is bring the numbers to the front and then we roll with the powers separately. Okay, so we bring the numbers to the front, so we get 2, we do times 6.75, and they become their own little thing, times 10 to the power of 3 times 10 to the power of 5. Okay, so we've just taken those numbers from both of them. So we've taken this number here and this number here, and we've popped it in here. And then we've just taken the powers here and here, and we've popped them down here. Okay, so now it's just a case of working that out. So if we do 2 times 6.75, we get 13.5. And you can do that by doing 2 times 6, which is 12, and then 2 times 0.75, or 2 times 3/4, which gives you 1.5. So then 12 plus the 1.5 gives you 13.5. And then we've got our times 10. And remember indices here, if we have powers that are the same, our laws of indices say we can add the powers together. So that becomes 8. Okay, so for those of you that aren't following, let me write this in a colour on the right hand side. So there's a rule of indices that say a times n times a to the n equals a m plus n. Okay, so what this means, if we have two numbers that are powers of the same base, so for example 3 to the power of 5 and 3 to the power of 4, we can just add those powers. So you go 5, 6, 7, 8, 9. So that becomes 3 to the power of 9. If we had 5 to the power of 2 times 5 to the power of 7, that becomes 5 to the power of, you've guessed it, 9, because 7 plus 2 equals 9. So going back to our example here, where we had 10 to the power of 3 times 10 to the power of, whoa, that doesn't look like a 10, 10 to the power of 5, that equals 10 to the power of 8, because 5 plus 3 gives us 8. Okay, so looking back here, whoops, that's the wrong colour. So looking back here, when we're looking at that 10 to the power of 8, that is how we got our 10 to the power of 8. We added those powers together. Okay, so that gives us a final answer of 13.5 times 10 to the power of 8. Voila! That's not too bad at all, was it? So the key thing there, when we're multiplying and dividing, take those numbers to the front, multiply the numbers, and then add the powers together. So we get 13.5 times 10 to the power of 8. Now, actually, what I should say here is that's not actually in standard form. Because, of course, standard form needs a number between 1 and 9.9. So to finish that off, it would be 1.35 times 10 to the power of 9. And then that would be the answer we'd give in an exam. That's our final answer, okay? And the reason we've got that is we've just put that 13.5 into standard form. So we've moved that over a 1, and so we've added the power up 1 to get to 9. Cool. Okay. So key rules there with multiplying and dividing. Take those numbers at the front, times them, and then add the powers. Let's look at one more. This time, let's look at a dividing. So let's get, okay, so 1.2 times 10 to the power of 8, let's do. And this is going to be divided by 2 times 10 to the power of 4. Okay, so you'll notice here the big difference, we're dividing, not times, but it's exactly the same, okay? So the first thing we're going to do is put 1.2 divided by 2 at the front, okay? And then we are going to have the times, because remember, we are timesing them, to 10 to the power of 8 divided by 10 to the power of 4. Okay? So we've taken those two numbers at the front, so the 1.2 and the 2. We've taken both of them out. Oops. Now, because we're dividing, that's why we've got our dividing sign here. We then have our times in the middle, because those numbers are times by 10 to the power of something. So that's where that's got down, and that's being dragged down there. And then we have 10 to the power of 8 divided by 10 to the power of 4, because again, that middle bit is coming through. So we then do 1.2 divided by 2. So imagine that is 12 divided by 2. So 12 divided by 2 equals 6. So then 1.2 divided by 2 is 0.6. To get 0.6 as our beginning number, I'll rub that out on the side, times, and then it's 10 to the power of 8 divided by 10 to the power of 4. Now, just as I did previously, I'll show you on the right-hand side the laws of indices. So the next law of indices says a to the power of m divided by a to the power of n equals a m minus n. Okay, so basically this is if we're dividing by powers which have the same base, we minus the number. So 3 to the power of 5 divided by 3 to the power of 2. That just means 5 minus 2. So 5 minus 2. And of course, 5 minus 2 is 3. So we can just write 3 there. Similarly, if we had 7 to the power of 9 divided by 7 to the power of 2, we'd have 7 to the power of 9 minus 2, and 9 minus 2 is 7, so we'd have 7 to the power of 7. So then going back to the left-hand side, 10 to the power of 8 divided by 10 to the power of 4 is going to give me 10, 8 minus 4, which is going to give me 4. So then my final answer becomes 0.6 times 10 to the power of 4. And that is in standard form there. Sorry, that isn't in standard form there. Again, because we've got to do that final one step. The number's got to be between 1 and 9.9. So put that in standard form. It becomes 6 times 10 to the power of 3. Okay? So we're moving it again one place over, so we lose a number there. Good. Okay. So far we've had a go at multiplying and dividing. And the key thing for both of them was to take the numbers at the front and pop them and do their division or times first, and then worry about powers. The next thing we're going to look at is addition and subtraction of standard form, okay? And addition and subtraction is of standard form. There's a different rule, and the key word here is to make the powers the same, okay? So we're going to make the powers the same. So let's look at an example. So So 9.8 times 10 to the power of 4, and that is going to be plus 6.6 times 10 to the power of 3. And these are typically non-calculator questions. Okay, so they're generally in your paper one where you haven't got a calculator, and that's why you need to use your knowledge. Okay, so addition and subtraction. First thing we do differently, so if it was times or multiplication, we'd put the two numbers at the front, but because it's addition here, so this is addition, we want to make the powers the same. So at the moment, we've got 10 to the power of 4 and 10 to the power of 3, and those powers are different. So we want to make them both the same. So I'm going to make them both to the power of 4. So my 9.8 times 10 to the power of 4 stays as it is. That's the same, that's fine. But I'm going to make this one 66. Sorry. 0.66 times 10 to the power of 4. Okay, and the reason I've done that is because to increase that one to go up, we make the number smaller. So we go back. So now we've got two numbers where our powers are the same. Okay, now once we've got that, then and only then can we take the numbers that are the same. So we do 9.8 plus 0.66 at the front, and that becomes times 10 to the power of 4, because they're the same. So what we get here is then, if we do our 9.8 plus 0.66, we get 10.46. So 10, well, that doesn't look like a 0. 10.46 times 10 to the power of 4. And remember, this isn't yet in standard form, so we've got to do that one final step. If I get rid of this addition, that one final step becomes 1.046 times 10 to the power of 5. And then that number there is in standard form. So the numbers between 1 and 9.9. So it is in standard form. And that would be our answer. That would be the one we give to the examiner. Okay. So let's have a look at another addition and subtraction. This one is going to be a subtraction one, okay? So we're going to have 7.6 times 10 to the power of 5. And we're going to do minus this time rather than adding. 8. Whoa, that's a bit of a big 8. 8 times 10 to the power of 3. Okay, so here, remember the rules are the same, okay? So adding or subtracting, we have to make the powers the same, okay? So what I want to do here is I want to make both powers to the power of times 10 to the power of 3. Okay, so here, we're going to make this 760 times 10 to the power of 3. And then we're going to do minus 8 times 10 to the power of 3. Okay, so now the powers, so times 10 to the power of whatever, are the same. They're both times 10 to the power of 3. When you're doing addition or subtraction, that's really important. Okay, so then we do 760 minus 8 in the first bracket. And that's going to be times 10 to the power of 3 in that second bracket. Okay, now then 760 minus 8, that gives us 752 times 10 to the power of 3. And then we have to do that one final step, and we have to put it back into standard form. So in standard form, that becomes 7.52 times 10 to the power of 5. And that would be your answer, okay? So, I hope you found this video useful. We've covered what standard form is. We've covered all about multiplying and dividing, as well as adding and subtracting numbers in standard form. And we've covered lots of different examples of that. Any questions, as always, drop me a line. Otherwise, hope you found it useful and good luck. Bye.